Hello everyone, we're continuing with day 21 part 2. We just solved part 1. Let's as usually do copy on the given day and paste. If you're new to the videos that we're doing, we're solving everything in Go. Usually what we do is we have initial prompt, we're asking for the second part of certain challenge, we have the test example and the real input. We are reading it as a file, and more or less that's the whole thing. The interesting part was that for day 1 the challenge was relatively simple. We have a board that was clockwise arranged, and we have positions that we were starting from and throwing a dice, and after a certain number we were going to the beginning, and our dice was deterministic dice that was going from 1 to 100 and so on, and we needed to calculate how many throws will be before some of the players win, and after that multiply the number of roulette numbers to the number of the losing player and giving that as a result. And we need now to do the second part of the puzzle. It is time to play the real game. The second compartment opens this time the label Dirac dice. Out of it falls single 3-sided die. Okay, we have a die that is 3-sided die, these Dirac dice. As you experiment with the die, you feel a little strange. An information brochure in the compartment explains that this is quantum die, okay, for that and Dirac. When you roll it, the universe split into multiple copies, and copy for each possible outcome of the die. In this case, rolling the die always split the universe into 3 copies. One where the outcome of the roll was 1, one where it was 2, and one where it was 3. The game is played the same as before, although to prevent things from getting too far out of hand, the game now ends when either player scores reaches at least 21. Using the same starting position as in the example above, player 1 wins in universes, while player 2 merely wins in these universes. Using your given starting position, determine every possible outcome. Find the player that wins in more universes in how many universities does the player wins. Okay, now let's go here and prepare our second input. We needed to little bit modify the program, but let's see how we usually were doing that by we were using this. Okay, thank you, that's the program that it solved it, and after that we are actually asking for the second part. Okay, I like this approach, and let's use it in here. Thank you. I have, and actually our go and code we needed to modify it here a little bit, and it's quite short. And what's the task? We go to here, part 2. Let me grab it. And in our, that's our new input, and here let's make tweak that, and having our test input. Let's see how it will go. If we say okay, the program that we got, it's working, so on, but we need now a new one. Okay, now it's telling us that we have this quantum die, and the new winning condition here is the modify Go program to solve the it's checking player score. Okay, nice. We have this new play. We have player position, score, round count. I really like how it's organized. And but 1 second. Here we want to know but where is in how many universes player 2 wins. Oh, sorry about that, I actually move the wrong input, should be in this file. Okay, let me have this part 1 in here. Let me add that, sorry about that. I simply forgot the previous time when I was solving the task actually to get the suggested program and to save it. That's from the previous task. Tank, I don't need this one. Tank. Okay. Let me do git add day part 1 and simply have all of them to know that they're saved as they were. Now I have this one here. I have the answer. Let me go to actual code. That's the program. And it's getting how many times it's player 1 winning. Probably we'll need for player 2. And player 2. Okay, let's see how it gets. Player 1 wins in 1 second. That seems very different. Player 1 here wins in many more universities. And what about player 2? Using the same starting position as in the example above, player 1 wins in, we have state but play. I actually don't find that very remotely true. Yeah, let's see. Okay, and we're doing the recursive call and we're adding it. Okay, that seems about right. Okay, that seems significantly better, at least at first glance. why is so small the number? Think it's something. But let me see why is this. Growth returns, blah blah blah. If I do that, for each possible outcome of the die. Okay, let me add emphasis on the. Let me emphasize on this one. Not. Not sure why would I. We would expect that should be max Go. Okay. Okay, it's minus. Very nice. And now I need to. Okay. Trying to. Yeah, it seems like we'll simply time out. Yeah, the problem with the no, that's like wrong. Wrong. Probabilities. That's interesting. Approach forward. Yes. Yes. Okay, let's see. What is this one then? Okay, that's like 3-sided dice. Okay, moving 3-sided, but the dice should be the dice shouldn't be deterministic. Let me look at that, because this one there is no this is a quantum die. When you roll it, the universe splits into multiple copies, one copy for each possible outcome of the die. But does this mean 100, or the die is like from 1 to 6? Split the universe into 3 copies. One where the outcome row was 1, one where it was 2, and one where it was 3. But the previous die was 90-side die. And this one was so little because of that. But what about if my die is to 100? 1 to 100. Let's wait and see if this one will complete. Each top. There is no way. It's simply top. Okay, we can see that memory usage and so on is fine. It's simply the CPU. Let's wait a little bit. Okay, here has some memo, some not about if it's like this kind of normal dice. Why is this? Okay, that doesn't look correct. But what about? Yeah, it doesn't look correct either. What about if I have two dices? I don't have that whatsoever. What about too much? Shall it be like 1 to 6? Mm-hmm. Hmm. Yeah, let's see. I still didn't understand. Is that the normal dice? That is up to 100? Mm-hmm. Okay. Okay, it's still running and will never finish. However, I decide to simply to get rid of our initial program that was a little bit confusing and simply to ask the new prompt GPT-4, and that's like a new start to simply ask for entire question and see how we'll do. Having our favorite stuff with, okay, that's the task. And having here simply this stuff. Write a graph program that solves the second part of the task. Okay, let's see. Let's go deep on this one and stop wasting our time with simply something that will probably not work. Okay, that looks promising so far. Checks. Rolling 3 times. But is it rolling? Position -1. That. Doesn't seem to me like that's approach that will get me anywhere anyway. Okay. Now what about if that's 100? Now that quite off. Let's see. Port size, so it's 10 threshold is I mean that's really Okay, in theory, that's our program. Cursive function, we define it, assigning the function, nice. I will say that this one is better, although it's very subjective. Let me try some of the problem to see if some of the other programs would be able to solve it. Okay, let's see. What about checking the for loop? Let me put it as a prompt here. So and we have the answer, which in the case of Saga is this one. Let's see how it does. Yeah, I mean, the other one probably will never ever finish. Sure how far this one will go, but let's stop the original one after 3 minutes 20. It's simply totally wrong. Yeah, I mean, at the stage now you're warmed up. It is time to play the real game. A second compartment opens, this time labeled direct dice. Out of it falls a single 3-sided dice. Okay, we have 3-sided. As you experiment with the die, you feel a little strange. An informational brochure in a compartment explains that this is quantum die. Which you roll it, the universe split into multiple copies, one copy for each possible outcome of the die. And this die is three-sided, okay, then there are three outcomes. In this case, rolling the die always split the universe into three copies, one where the outcome of the roll was 1, one where it was 2, and one where it was 3. Okay. And the game is played the same as before, although to prevent things from getting too far out of hand, the game now ends with either player scoring reaches at least 21. Using the same starting position example above, player 1 wins universes while player 2 merely wins in significantly less. Using your start position, determine every possible outcome. Find the player that wins in more universes. In how many universes does the player win? Okay, why I have 3 dice? I actually think that's kind of wrong with this setup, but I mean, I'm getting the following error. Come on, it's more and more, I guess, stuff it's getting. It seems like it's okay, play game and I have memo. Versus, okay. Okay, that looks so far promising. Let's see how it works with the parsing. I can see already that the parsing it's kind of wrong. It's missing this. 1 second, this parsing was actually wrong. But 1 second, how is that even working? Shouldn't that be like that? And this one again. 28. Blah blah blah. Okay, that's nice. Where is the board size? Okay, it's too. Because they have the same kind of error. Okay, at that stage it's clear that winner score, that's very interesting approach. It's like a completely different program. Yeah, on that stage. I think to call it a day. I kind of had enough. There's next. Yeah. Could we ask simply Bing for this? Okay, let's imagine that I'm sticking with this version that I'm running at the moment. Let me add it here. Oh, that's like so perfect. However, what's partly interesting is to ask Bing for solving this program for me. I mean, I don't think it's a little bit too big for Bing. Or probably it's not. Let's do it the Bing way. Okay, it's too big and by huge margin too big. Let's stop with this one and go with this one. Okay. Up. Part 2. Okay, without this, so let me see. Oh, it's even more deleting. Like what? It's like okay, that on theory should be enough for Bing. Again, let me give the task. But this kind of stuff for beyond my capability and so on, it's actually I mean, I understand that there are some students that doesn't want to cheat or some kind of such stuff, but in any serious thing, I mean, this kind of that's beyond my capabilities and so on, it's actually making the system absolutely useless. In one moment, yeah, that will become such a drawback. Yeah, that's still running. That will never complete. Mm-hmm. Okay, interesting. Now it's grabbing with F scanf. Make main range. No, that will be too much. That will run out of memory. I mean, that has even less chance than the previous one. Now this logic looks to me a bit wrong. Why is this dissect board size? I mean, that will crash immediately with lack of memory. Anyway. I mean, that's this doesn't look whatsoever promising. Let me stop the other one and see with this one. Yeah. As I would expect, let me double check that this one here it's working correctly. Okay, and what about the one with 2? Okay, that's perfectly fine. It returns 0. It is not correct, but cache key. Okay, that seems quite promising. That seems very interesting. Cache key, first cache. Memorization, verse 1. But yeah, I mean, at that stage, I think that splitting it and making it solvable in a reasonable time, it's mm-hmm. No, that's completely wrong. I mean, that's simply just for 1 second. I've never checked how here the parsing is done. Okay, that's look very clever. Yeah, that's actually clever. Let me copy it here. So actually this stuff that doesn't really work, and man, God sake. Mm-hmm. Okay, it seems like there is no way for that to be solved in reasonable time. Yeah, it's simply too big. Okay, I think to close my attempts for now, and hopefully day 22 it's any better. Thank you for your time, and let me see you in the next video. Bye. Let's watch another idea, one video from AI Explained, that guy was talking about how we can try to tell ChatGPT how confident is in its solution, and to see if that will help, because so far we haven't been able to generate one program that it's actually solving the second part of the challenge. And one technique that it suggested is simply to actually ask GPT-4 if it's confident that its solution is actually correct and would perform as expected. Let's see if this technique that I have heard just will be working, but let's first see the solution, because so far all the other approaches seems to not be working. But let's give a try of that idea for simply having okay, here I can see the reading. It seems correct, that part seems correct, that part seems correct. Okay, and we get the two answers. Let me say a new start. Okay, here we can see that it's kind of completing, but it's not really correct. But before to go there, let's see what did we ask ChatGPT. Oh, 1 second, we kind of wrongly asked ChatGPT because we include in our answer task 2, but we don't want to have this part. We want to have our first solution and to have it adjusted with the task. Sorry about that. This is for the system split first. So far so good. Both star wins. We have these functions. Play. It's -1. They're probably not. There is kind of check. Okay, that's invalid Go syntax. Let's see. Because we're checking positive or not. Let me ask, do you think your solution is correct? Correct Golang program that takes to account all requirements. Does not correctly. Okay, let's see how this works, because we have this initial program that I previously was kind of having it here. That's the new start. Let me use it prompt 1 GPT-4. After that we have the answer. Which is this kind of program that have invalid syntax and so on. Why is invalid syntax? Because Go doesn't have this ternary operator, etc. This one up here, that's not valid Go. But apart of that, let's see. After that we prompt with prompt 2, which is actually this tactical prompt in which you're asking, okay, are you sure that what you gave me is actually what I ask about and what actually solve my problem and so on. Here we can see that part corrected and so on, but let's now it should compile it's still Are you sure? Are you sure that this program takes into account all the requirements, including that the universe which the games take place should split on each turn. Okay, let me see how that will go. You're correct, my previous one did not properly account the universe splitting. Okay, because here, and let's see, because it's a little bit hard to say in this context if really it was correcting a mistake and so on, but was kind of doing the same thing when we were asking previously. Okay, now we're asking our third prompt. Here like that. Prompt 3, nice. Absolutely amazing. You're correct. I mean, why is this truncated? Not completely sure about this one, to be honest. But let's see how it gets. This problem is a little bit strange. Return units. Why is this like that? Like I'm getting 0. Why is this stuff corresponding to current turn calculated as the universe count accumulated with each call play? Does it? No, it's minus. I think that's wrong. And let's see if this tactic can help in such cases which the requirements are very complicated. These kind of programs are really challenging. Okay, I'm seeing 0 here for score 2. I'm not sure why would it be 0. Score 2. I have this person. I'm not sure that that's doing the job either. Are you sure that this program follows the requirement from the task? The full task was as full, and you need to solve part 2 of it. And what was the full task? Yeah, let's see. Here is blah 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 of this text. Prompting here. Okay. Okay. Okay, let me ask more specifically for if 1 second. I think that I need to specify here why when I run the program with the test data, I get much smaller number than the expected result from the task. Do you have any idea why that might be? Okay, let's try. Okay, blah blah blah. Let's go for it. At that stage, I'm pretty confident that will not work, but prompt 5 GPT-4, that is, and the answer is, I apologize, but it's actually still writing the same kind of program. Oh. Now at this time it's even again with the syntax error and so on. I mean, it's not getting anywhere. Let's see. Okay, now it's going to the other variation that was previously. Yeah, now here it's okay. The first, the second one. Yeah, this one it's again this ternary operator that doesn't exist in Go, and that's actually it's again stop. It's with this kind of prompting in which it's actually asking to correct its mistake. Yeah, I'm not confident that how these results that are talking for better responses in this case are really based on enough statistics. From what I can see myself, it looks like that were a few occasions in which, okay, this self-reflection seems to work, but it's not actually, by no means it's reliable. And yeah, in this case, let me leave it to that stage and try to tell it that it's actually not correct. I mean, even with a small situation here, that's clear that will not compile. It's simply, yeah, there's no line 26, it's simply invalid Go syntax 35 Yeah, this is not correct go. Are you sure that this program is correct? Go on. Program N whose all of the required task requirements. Could you check step by step? Okay, let's see this more detailed explanation. Yeah, it's simply. Yeah, I don't think it's reliable by any means. Yeah, I can see that it's at the moment it's actually struggling brutally. It is repeating the same mistake with invalid Golang syntax. Don't try, it isn't helpful. Okay, I think it's clearer and clearer that will not be able to solve this task. Even having access to running its code and so on, it seems, yeah, simply struggling with that. Although to some degree the amount of code and the logic that it's writing is almost there. I mean, to be honest, it is very impressive, but still. In this case, is for example with this memorization tactic and all of this stuff, it's simply getting relatively complicated even to follow and to analyze the problem and so on, and it's ends up being very unreliable, although in this case it's getting to some relatively fine answer, and it's better than, in my opinion, it's better than the other one, although not correct. Is definitely compiles and so on. For my criteria, would it be let me add another prompt. It's because it's actually, do I need really to add another prompt because it's this prompt? I simply revisit. Let's see in that scope program. Still the final answer is much less than what is the expected. I'm getting what I'm getting when I'm running it. I expect it looks like the figure looks nothing. Could you think step by step if the task is correctly implemented? I appreciate your passion. After further investigation, I found the issue in previous solution. The previous solution doesn't account the fact that the universe split in each die row. The number of universe should be multiplied by the number of possibility of each step. Here is the updated solution. The number of universes should be multiplied by the number of possible of each step. Okay, does it do that? Where is the multiplication? State. So the result. State. Okay, let's see, but yeah, I mean, from what I'm seeing, it's actually not following its words, because it's saying here, rightly so, the number of universe should be multiplied by the number of possibilities in each step, which is here when I'm if I multiply it like that, getting completely different solution, because I have from 1 to 10. If I multiply it by 100, I'm going to get, yeah, let me ask about that. Oh, what is this one? Is 0, it's 10. You talk about this part, but I could not see it implemented in the code. Why is this? The explanation provided was not accurate. The key change okay, that's nice. But it seems you ignore this part. However, the updated solution provided this account for that. But should it add that? Still, why I'm getting so small suit number? There should be some logical mistake with the of counting the winners or and with the universe splitting. You're correct, and apologize for our signal previous. The does not account the number of universes for each possible outcome. To fix this, we need to multiply the number of winner universities for each outcome by total number of universities that can result from the roll dice. I have bet 3. Yeah, that sounds reasonable to me. Hey, I like how it digit the file and so on. And it's absolutely fine. Yeah, I can read it. Wonderful. In our test it's 4 and 8. Okay. Isn't that like by 6? 3 sides dice, and I have like 6 here. Too big. Still getting. Okay, let me ask us with the actual input 5 and 6. I mean, that's absolutely clear that instead of 'okay, now it's saying it's alternative approach. Let's see. It's yeah, more or less it seems. Oh wait. Interesting. Instead of 1. But from where is getting this weight? Three by three. Interesting. And let's see. I like now how stop reading from the file. I think it's time. Wait, actually dealing with the file. Still getting and the winner is 2 instead of player 1. Much smaller than expected. Let's see, let's push it hard and hope that in okay, which one will account for the universe correctly? I think if I was using binary search after the first attempt, okay, now I have the weights for both. And before that, what was the weight thingy? Was only here, but wasn't using anything here. Okay, it's super interesting. Really interesting. Very, very interesting. Okay, how much of that? Mm-hmm. Getting I expect again how it's going in this the rows thingy that I never understand what does it mean really. Because we have 3 universities and in each of them can be 1 to 3. Yeah, it might be the case. Hard to say, hard to say. I really like that somewhat evolved to have it hard coded here. Which is very interesting. All that said, still I'm getting okay. And I think at that moment it's simply not going to happen. By 3. Tak. Mm-hmm. Mm-hmm. It with the woman, that's very interesting. Looks more like a random guessing. I mean, it makes sense. I'm doing kind of the same thing at that stage, but yeah, it's a bit. I can't. It did not change anything. Mm-hmm. Here, after running it hundreds of times, is that one by one the same thing? Yes, so far we hear the weights. It's a bit different. Here is multiplying by weights and so on. Yeah, it seems simply not being able to do it. Which, in all fairness, yeah, it's understandable. And this logic for telling it to look its mistake and so on, it seems it's kind of guiding, but yeah, it's neither is better. Hey, this one doesn't use anything. Oh, all of them doesn't use anything. Let's hit the numbers hard coded. Why is this Roman man plus 1? Next, wait. The 3 rows. Don't know. How this will look like a random guessing kind of thing. But I suppose at that stage, yeah, it's understandable to be then the case. Okay, and was time isn't true. Let me go to the prompts and yeah, this makes sense. Does more of this depth here. That's interesting. That's some approach that I haven't seen so far. Original stuff here. Top with this, not reading it from a file. Let me try this last one. Didn't work, but it's wrong in a different way. Yeah, I mean, at that stage, I think to call it a day for this task, it doesn't seem like a solvable, and let's see how we'll go with day 22. Thank you, hope that was somewhat helpful.